So, in episode 1 or part 1 I showed my build of my CNC machine, and I also showed that I had some issues with the Z-axis and also with the spindle. So here I will upgrade my Z-axis and I will purchase a new spindle. And here you can see the parts after I split my Z-axis, and I want to create a new platform, a new Z-axis. And the reason is that the new spindle is heavier and it is also more powerful. Also, as you can see here, the gantry itself needs some reinforcement. I think it'll be a plate or something like that. It's not that stable, as you can see, and I need somehow to make it more rigid. The reason why I also want to make it more rigid is I plan to upgrade. So I will change the wheels to some rails like these. They have been bought at AliExpress. They were not cheap, but they were not expensive either, but it seems to be a good choice. And beside the rails, of course, there's also the trolleys where you can mount the Z-axis. So I was wondering how much extra weight it will take. So I put everything on my scale to figure out what is the addition of weight on my gantry. But as you can see in a moment, it actually more than 5 kilos. So the scale is only going to 5 kilos. So I had to divide it and measure in 2 parts or 2 steps. And you can see the rails itself is about 3.7 kilograms, and for the trolleys it's about 1.6, so a little over 5 kilo is added to the gantry. The rails on the x-axis is going to be one in top like this and one on the side like this. When I do this, I have an idea how I can put my Z-axis together. And then of course for the Z-axis I also have 2 smaller rails or shorter rails, and they are going to be approximately here. After a while I finalized the mounting of the rails, and here you can see the rails mounted, and the trolleys, or I also think they are called sliders. And also in the same time I put in some reinforcement in the back of the gantry. I put in 3 plates here, small plates, and maybe it should have been 1 big plate, but this is okay in the beginning. And here you see the sliders. They are a little resistant here, but it's not much, and actually I think it's working pretty okay. And if you want to have something similar like this, here you have the number, so you can see what I purchased. I put all the parts from the Z-axis, or the parts needed for the Z-axis, on the table, and I try to play a little around to figure out how to align all the parts, and eventually I figured out how they should be put together. After I figured out the size of the back plate for my Z-axis, I cut the piece of metal or aluminium on my table saw. So it's actually pretty easy and accurate to use my table saw to do this. Maybe you have seen one of my other videos with a CNC. It's a small CNC from, I think also from AliExpress, something like that. I use this to mark up the holes, or where to have the holes in the back plate. It's actually pretty accurate and it works fine. And then I get a more precise setup of the holes than if I were just using a piece of paper with some marking, or if I try to mark it with a ruler and a pencil or something like that. And it works pretty okay. So again, yes, I only want to mark the holes, and later I will take the plate to my drill press, and there I will drill the holes to the right sizes in the places where they need to be. I also think to remember some of them need to have a thread, so I will also thread the holes. On the drill press, it's just to find the right bit or drill, and then it's just to drill the holes. And because they have the mark, it's very easy, and it only takes 5 minutes, then you have all the holes. And then, as I also explained before, some of the holes need a thread, so I will just thread the holes. And after I have done that, the plate was actually ready to try to mount and align the parts and see if everything is as I want them to be. Time of truth. Let's see if it actually is aligned and how good it actually fit, how precise is it. So I put it together and I measured, try to figure out what is the distance and is it okay according to the dimensions I put in my CNC when I created the holes or the marking for the holes. And it seems to be okay. There is a difference or tolerance on a couple of millimeters from one end to the other end, and I think that is okay. After I mounted all together on the back plate, I wanted to measure once more, and because I had the tolerance of a couple of millimeters and the holes in the rails are a little bigger than the bolts or screws, then it was actually possible to align so they are total parallel. The stepper motor, of course, also needed to be mounted somehow. So in a local store I found this metal angle. Normally I think these are used for building houses, but it has a nice 90-degree angle and it's very stiff, so it suits very fine for the purpose here. The end result for the Z-axis is here, and you can see I have also mounted the stepper for the X-axis. I have some limit switches, they are not mounted yet. You can see the rails, and also you can see that I still use a belt. I think maybe later I will try in this space here put in a spindle, but that will not be now. So this is how it ended up. As you also can see, I used some metal angles for the X-axis. It's actually pretty easy to use, and they are also relatively easy to find, and they have a good price. And first run to see if everything is working smoothly. Here I run the X-axis first to one side and then to the other side, and everything works fine. And after I did that, it was time to try homing, and at this time here I have my limit switches in place so I could test them as well, and everything seems to work fine and run smooth. So I just made a homing here where I go back to the start point. Then it was time for the spindle, trying to figure out how the spindle should be mounted. And as usual, I use my Fusion. It's a really good software and I love it. It's really easy to use and it's very precise. And despite I can do it, the 3D design, I can also use this the same software to create the G code for my CNC. So all in all, I think without this tool here, it might be a little more challenged. Of course, it is possible just to draw something on a paper and mark it up and then have some marks you kind of mark up from the paper on the back plate or the plate here, but it's not as good as doing this or all this in the software and run it on a CNC afterwards. So here I show how I do it, and also I show I just want to mark, so only the top of the drill will be used. And here you can see a simulation, how to run, so it won't take a long time to run this small program. And then export it to a file so the CNC knows what to do. And here are some different parameters. I normally just set up once and then just click OK, and here you can see the drill program, the G code for the drilling. I have an idea that it is a good idea to raise the Z-axis before running X and Y, so I normally put it before X and Y operation. It seems to be the right thing to do. And then in the end here, I just get rid of a blank line, and then the program or the G code is ready for running on the CNC. After mounting the plate securely on the bed here, I started the G code, and I don't think I'll say much here. I will just lean back and enjoy the machine doing all the work. If you remember from the software and the G code I just produced, there's a lot more holes. I got a little wiser between I did the previous job in the software and until I figured out how many holes actually needed for this plate for everything to work. The drill press is again used to drill the holes. First I find, of course, the right drill size for the holes. Some of the holes also, as I recall, need some threads, so they will of course also be threaded. And after the drilling and all what needed to be done, the final result is here. You can see all the holes. So mounting all together, doing the first test, running with the Z-axis and doing a home to see that all switches are working as supposed to, seems to work fine. The spindle is a frequency control spindle, also called VFD. I bought it as a kit, so to speak, the spindle and the VFD together. Here you see numbers of the spindle. These numbers need to be put into the VFD, so the VFD knows how to send the right signals, so the spindle will do what it is supposed to do. I plan to use a fluid NC board to do all the testing. For you who do not know this, it's actually pretty smart. I think they work pretty well and like the idea how they set up and how they run with a config file. It's very similar to a Voron 3D printer I have. To set up the VFD itself, it's also pretty easy. There's a manual together with the VFD when you get it. And according to this manual, I think there's 50-60 different parameters to set. But I think to remember only 8 or 10 is needed to get this up run, so everything is working as supposed to. And the menu is very easy to walk through. You just use the buttons on the VFD and you just take the parameters one by one and then set according to the numbers again from the spindle, so everything will be aligned. Then I wired up between the VFD and the spindle. I found the board and I hooked it up to my PC so I could test the axes. They were working. You can see the blue LED light here is lighting up. That's for the axes when they run. And everything seems to work fine and I have a good connection to the board. The first thing I need to do here is to set the signal 0 to 10 volt. That's the signal that will indicate how fast the spindle will run. So on a scale 0 to 10 volt, the scale will be that the spindle will run from 0 to 24,000 RPMs. When I anyway play a little around with all the signals here, I thought it might be a fun idea to look at the signal itself. As I recall, the signal should be a PWM signal, pulse width modulation, and at this oscilloscope here, it's pretty easy to catch the signal and try to monitor it on the screen. So I will try play a little around, putting in some RPMs for the spindle and see what's going on the oscilloscope. In this case here, you can also see different numbers. I try to play a little with the resolution to find the right or good resolution so I can see what's going on in top and bottom of the signal. You can see, if you look at the monitor, you can see the peak voltage is 10.545 volt, and there's a mean, an average of 4 volt. So that means the spindle will probably run about, let's say, about 8,000 RPMs at this point. And also you can see they communicate with 5,000 Hertz. This is also a number you put into the VFD. So the VFD know what's going on when it gets the signal from the controller board. And I want to adjust a little closer to 10 volt in the voltage. So I just use my little tool here, and then I play a little further with all the RPMs on the spindle to see how the signal is changing. And I can see every time I set the number for the spindle a little up, also I can see the mean value for the voltage is going a little up. I think 7.3 here is around 20,000 RPMs. And you can see the signal is changing again. Here it's about 22,000 RPM, and finally I set it to 24,000 RPM, and now you can see it says approximately 10 volt. And then I just shut it off, and you see now it's 0 volt, and now the spindle is not running. Going on to the CNC, I hooked up some test wire to test the spindle, and my cheap Chinese board here do also have the 0 to 10 volt control signal. So I hooked everything up, and I loaded a small program in my CNC software, and when I ran it, I could see that it started at 6.1 millivolt, meaning that the spindle was not running. And then when the spindle started running, you could see that the voltage is going up to first 6.1 volt, and then it changed to 24,000 RPMs. That means it goes up to 10 volt. So everything seems to work as supposed to. Then it was time to test if everything was working. So the first cut here with the new spindle and a small V-beat, it's not running that fast, so it's more like seeing that everything is working, and also trying to test new rails, see that everything is running smooth and in a line. So I made this small test cut here, and as you can see, everything is working really good, and I am really pleased with the result. So now I just have to tam or trim and set up the spindle so it runs through for all 3 directions, X, Y, and Z. So, but the next thing I think I will do is look into dust collection. So I will see you in part 3 maybe, where I will show how I actually create my own dust collection and all the work that is to that and get it up running. But it's actually working pretty good, so thank you for watching, and see you next episode.